Hey everyone, welcome back to Software Testing and Quality Talks by Venkat Ramakrishnan. Today we have with us Eran Kinsbruner. He is the Global Head of Product Marketing and Brand Strategy at Lightran and a best-selling author known for works like Continuous Testing for DevOps Professionals, Accelerating Software Quality, ML and AI in the Age of DevOps, and a Front-End Web Developer's Guide to Testing. A finalist for DevOps.com's DevOps Evangelist of the Year in 2021, 22, and 23. He has extensive experience in software development, live debugging, and test automation at companies like Sun Microsystems, Newstar, Texas Instruments, and General Electric. A patent-holding inventor, blogger, keynote speaker, and thought leader. Let's welcome Eran to the show. Hi Eran, welcome to STQT podcast on software testing and quality. It's great to have you here. It's a pleasure to have somebody from the community who have been there around for a long time. I would like to give you a warm welcome to the podcast. So let's go ahead and get started. For the sake of audience, can you tell me about yourself and what you do?
Of course, Venkat, and thank you for having me. As you mentioned, my name is Eran Kinsbruner. I am the global head of product marketing at Lightran. Lightran is a developer observability platform that allows engineering groups to troubleshoot and do live debugging at runtime. We'll touch on that later on during the podcast. I have over 25 years of experience in the software development, software engineering domain. I have authored 4 different books in the space, and I'm based out of Boston. And again, happy to be here with you and discuss the topics around observability, shifting left observability, and things around that.
Wonderful, wonderful. It's great to hear about your experience, 25 years. Wow. And 4 books. What are those books about?
So they vary around continuous testing, shifting left software testing, AI and machine learning, aiding developers, challenges, and web-related technologies that can help web application developers deliver their code in a higher quality with tools such as Cypress, not Lightran of course, but Cypress and Playwright and other frameworks. So it's a variety of books, mostly aiming to, by the way, everything that we want to do. We want to deliver higher quality in production to our customers. And to do so, we need to employ the developers with a bunch of tools and practices. And these books actually cover both tools, frameworks, but also best practices on how to deliver high quality code in production. And it starts with practice and culture and other, things around that.
Wonderful. So me too, from the quality perspective, been working as chief quality officer. So I would definitely take a look at all of your books. And it's interesting that you pointed out about observability, which I've been tracking for a while, and especially on the production side. So before we jump into the observability, into the detailed picture of observability, let's talk about what observability is and what do you do with it, and how do you instrument that in the developer environment or the production environment? And so can you give some brief details about how it works?
Of course. So for those of you who are not familiar with the high-level term of observability, there are observability solutions. There are APM, application performance and monitoring, but observability per se refers to the ability for developers and operational guys to understand and infer the internal state of a system. A system can be a distributed environment, a very complex one, but the observability is based on external outputs and behavior. And you do so, or observability allows the engineers to gain insights into how the system operates through very common artifacts such as logs, metrics, traces, and in some cases, when you're dealing with live debugging, like what Lightrun offers, is also through snapshots, doing like breakpoints without really stopping the application. But at the end of the day, with logs and metrics and the things that I've just mentioned, the signals that I just mentioned, developers and when needed, the operational guys or the DevOps engineers can gain better insights into what is happening in real time, in production, pre-production, staging, in a feature flag based environment, so they can easily address an incident, an outage, a performance degradation, and these kind of things. And at the end of the day, when you are dealing with very remote, complex, and distributed workloads, you need to be very aware of the time it takes you to restore the service, right? Because every moment in time where your system is down, you have penalties, right? Whether it's an SLA, SLO that you are breaking, or simply business loss, revenue loss, because your application is down or it's not functioning as it should. And this is where observability, when it works fine, allows the developers to reduce MTTR, mean time to resolution, and overcome these challenges faster. So again, logs, metrics, traces, live debugging capabilities like snapshots are very good tools that when you are shifting all of that left and empower your developers, you can really sustain a very good and reliable production environment.
Okay, before we jump into the development environment and how to use observability in the development environment, I would like to ask you on your personal experiences on how the observability, be it in production, how did it help in terms of improving the MTTR and things like that? So can you share some experiences?
Of course. I see it almost on a daily basis. So actually, I've just published recently a white paper, and I won't name the actual organizations because I don't want to shame anyone. But in this white paper, I actually saw huge airlines and the insurance companies and retailers where their websites were down. And based on research that I've done, and by the way, I've also recently seen a research from Microsoft, they claim that dependency failures and code-related bugs are the most complex and sophisticated issues to resolve in production. So there can be, infrastructure issues, and there can be other related items as a root cause that causes production environments to fail. But the majority of the serious P1 issues that I've seen in production are due to code-related bugs, and dependencies. And these are very complex to fix because in other areas, you can do some rollbacks and things like that. When it's a code-related bug in production, it's very, very hard to understand and pinpoint which area in the code, when it was added, and why it causes this failure or performance issues or a crash, downtime, and things like that. And I see it almost every day, every week. You see it on Twitter, LinkedIn, and other social media where an organization, a very known one, posts that we are sorry that our system was down, blah, blah, blah. But at the end of the day, if it's not related to security and cybersecurity attacks, it's usually a code-related bug that failed to be spotted in the CI/CD during the development lifecycle, and it slipped to production. And when it's in production, fixing it takes a lot of time. This is where, gaining this shift left observability, you asked about how it relates to quality. At the end of the day, when these things happen in production, the brand reputation and quality perception against this business is very, very damaged. This is where when you are able to get better observability, better control as a developer in what's happening in your production environment, you can easily, let's not underestimate, not easily, but let's say faster, take over, the situation and understand why it's happening and how to resolve it, even sometimes before your end users are in panic mode, and you can address it much faster.
Okay, so you talked about code-related issues, code bugs,
Yes.
and things like that. And the other thing that you talked about is the dependencies. I am more curious about the dependencies. So what kind of dependency issues have you seen?
That's a great question. So obviously today, cloud native applications, microservices, and all the enterprise-related applications are built in dependence or relying on many open source libraries, many open source frameworks, and stuff like that. And when you are building this application, obviously you have we have seen in the past, all the log4j, log4shell, and other utilities, libraries, and packages that are coming from open source components. So these dependencies obviously are the backbone of your application. And if something either fails or you misconfigured the dependencies within your application hierarchy and tree and everything that you are building, obviously things can break. It's as easy as that, right? If you have a ladder that you need to climb and you're missing a step in the ladder, you will fail, right? That's exactly the same analogy to software dependencies. You are depending on a core package or a core library, and it's either outdated, misconfigured, or missing in your path. It's enough for that to cause a disaster in your environment.
Yeah, I could appreciate that because I have spoken to somebody else in the security field about log4j related things happened. So let's jump into more detail into what are the components of observability that can be done during the development itself, because you mentioned that production would be too late. Now, if we want to, if I can use the word shift left, if I want to do this earlier in the development cycle itself, what are the aspects in the development cycle where the observability can be done, and in what way? Can you deal a bit more detail into that?
Of course. So, of course, taking aside things that are not observability, which are obviously better software testing, unit and application testing and performance testing, which are obvious and needs to be done. This is your first safeguard for your application quality. But when you just zoom in to observability, shift left, and looking at how you can use observability in the software development lifecycle, you can use observability with the exact same components that I mentioned earlier, right? Logging and metrics and traces and snapshots, even in the pre-production environment, in the staging, in QA, within even CI/CD, you can use conditional logs and other instrumentation of observability and telemetry data that can give you visibility into what's happening even in the CI/CD, even before you reach production. The thing that happened in reality, unfortunately, and what Lighton is trying to do is to eliminate inefficient practice where developers are adding in the early stages of development many static log lines. Okay, these log lines are basically just a just-in-case practice. Okay, if something fails in our regression cycle or, God forbid, in production, at least we have some logs in place that we can understand what's going on. But this is a very costly and inefficient practice, which you don't need to do. If you have dynamic instrumentation, if you have live debugging, even in your software development lifecycle, you can query, you can inquire the code with dynamic logs, which are ephemeral, where they can be eliminated after you first run them. Let's say they can live for the length of your iteration, let's say for a few days. And with these telemetry instrumentation, dynamic logging, and stuff like that, when you add in the CI/CD, obviously the developers are running the code, are changing the code, are building the artifacts, and they can gain insights into their environment, into their IDE while they're building the application without the need to put this just-in-case static logs. They're doing it all as part of a dynamic process, which is not just cost effective because you don't need to pay all these logging aggregation providers, but you really see what is happening at runtime, even in the pre-prod environment.
Okay, so do you mean to say that these instrumentation will be part of the code?
That's the beauty of it. When you're dealing with dynamic instrumentation, you don't need to change, especially now when you deal with Java, okay? You can just run the agent, okay, alongside your deployment, alongside the application. It can be a Kubernetes cluster with multiple pods. You run the agent, which does this instrumentation on the fly, but you are not really changing the code, okay? You are inquiring from runtime, you ask for specific variables outputs and methods outputs and measuring the metrics execution time through the agent, but the agent does everything for you. The code itself does not change. You're not changing any line of the code. That's what dynamic instrumentation is all about.
Okay, so that means that I need to have a configuration file for my agent. And
yes,
in the configuration file, I would specify what are the parameters that I would like to monitor when I'm running the code, correct?
Even easier, you only need agent alongside the application. Again, depending on how many deployments, you will have the amount of agents running alongside. And everything that you just mentioned, asking or inquiring for telemetry and observability insights, you do it from the IDE, whether it's IntelliJ, Eclipse, Visual Studio Code, PyCharm, depending on the language that you're using. But you do all the back and forth directly from the developer station. And that's the beauty of it. You don't need to have a developer very specified in production deployments and Kubernetes clusters and stuff like that. The developer lives and troubleshoots everything directly from the IDE through a plugin. The plugin allows him to put any logs and conditions and stuff like that without really changing lines of code.
Wonderful. Got it. So I understand that in the development, it is very, very efficient and effective if you do that in the development environment. And you also mentioned that in the IDE itself, I can integrate the plugin and then I can get the stuff done. That's very efficient and effective. I have a thought process going on in parallel, like, would you have this observability in the production also in parallel, in addition to what we are doing in the development? Should it be there, or can we just eliminate that part of the production monitoring?
So it's a great question, Venkat. When you are dealing with dynamic instrumentation solutions, and that's a very innovative approach, these agents that I mentioned earlier, these are very lazy agents. They are just in a sleep mode practice, if you like, and they are running in production, but they just live in production. They are not doing anything from a footprint, performance implications, and anything like that. They only come to life when they get a request from the developer through a third-party server, if you like, hey, I need this log line added to line 25 in my source code in Java, Python, .NET, whatever. So having this safeguard in production really prepares you to everything that we've discussed earlier. When you have, because you never know when an outage is going to happen in production, right? And you're never going to know immediately what caused this outage. So just throwing log lines all over the place and having them live in your code in production is inefficient, because every time you need to do anything with these lines of code, you will need to stop the application in production. When you are working in a dynamic instrumentation mode, developer observability as we call, you have these agents in a kind of sleep mode, but ready to come to life when a production incident is happening, then the developer can inquire on demand only where and when he needs the log to be placed, so he can troubleshoot immediately and without stopping the application. And Venkat, this is the very important punchline with dynamic instrumentation, without the need to stop the application at runtime. Because with any traditional APM, which gives you the alerts, and with any traditional debugger from the IDE, it usually, when you put a breakpoint, it stops the application. When you want to add a new log line to your code, you need to undergo through a full CI/CD cycle. You don't have the time for that, and it's very costly. When you're working in a dynamic and live debugging method, you are always prepared. You are always ready to troubleshoot when an incident happens in production, because you have a blank code base, and you just, okay, I have this clean code. I want to add X amount of log lines and conditional logs or snapshots in production where the things actually happen. Okay, this is where the outage happens, and I don't need to recreate the environment. The environment is available for me, okay? And I immediately inquire, get observability insights to my IDE as a developer, to my VS Code or to my IntelliJ, and bang, in a matter of minutes, sometimes a few hours, the system is back online and the issue is solved without the need to restart, without the need to stop the application. And that's how production debugging is done in a safe and secure way. Less costly, of course.
Great. So thanks for going in detail about how it works. Now let's talk about testing. Now, how can testers get engaged in this process, and how can they help the developers in this whole process?
As a previous software tester and a VP of QA in my past, I love this question. And I think if the testers will be more engaged with the developers, after the developers are practicing this live debugging in production or pre-production, the feedback that they collect, the developers collect a lot of feedback from the observability practice and workflows. Let's take specifically an outage that happened in production. The outage happened, it was missed in the testing process. The developers were able to do a fix through live debugging. But the beauty of it is that if the developers feedback the testers with what happened and why it happens, this is where the gap in the software testing gets closed, okay? Because the testers now get immediate feedback from the developers on where the issue, in which function, which method, which functional area of the application the incident happened and why it happened, what was the user flow that led to this outage or crash or performance issue. And then suddenly, with this better together software testers and developers, the testers are able to maximize the test coverage and close this loop so this event doesn't happen in the future again. So I think that this shift left observability, even though we're talking about developers, can also benefit the testers from closing test coverage gaps into preventive actions for the future.
That's wonderful. That's wonderful. It's really great that developers can help the testers in
instead of fighting with them. Yes.
in closing the gaps. Great. Thanks a lot for all these details. So let's get into some fun stuff. So other than work, what are your hobbies and interests, and what do you do for fun?
Obviously, in the past, one of the hobbies was to write books. I think 4 books for now is quite enough. So I'm not writing any more books for now. I love sports. I live in Boston, so it's a winter kind of state, which means skiing and just traveling outside, playing only indoors, playing basketball. I love to do that. I have 2 boys, so obviously any activities as a family, I definitely love to do so. We have a lot of nice scenic views around Boston that we travel a lot. So yeah, keeping me busy, doing a lot of sports individually and with my family is definitely something which I love to do. And who knows, maybe a fifth book will come later on in the future, guiding the industry about developer observability, the new modern way of troubleshooting live environments and reducing this MTTR that everyone is trying to do. So maybe a fifth book will be as part of the hobby section coming later on. Who knows?
Wonderful, wonderful. It's great to know. So thank you so much, Eran, for appearing in my podcast. And I really appreciate your time and effort in making this happen for the STQT podcast. I hope that the developers and testers will benefit from the knowledge that you shared in the podcast. And I look forward for engaging with you in the future in many ways. Thank you so much.
Thank you for having me, Venkat. Thank you so much.
Bye-bye.
Bye-bye.